Good day, everyone. First of all, I'd like to introduce myself first. My name is SoftwareCharacteristics-Aguillon. I study Bachelor of Science Industrial Technology, major in Computer Technology at Surigao State University. I'm in my fourth year. Today, I'm going to discuss my topic, which is software characteristics. What is software characteristics? Software it is logical rather than a physical system element. Therefore, software has characteristics that are considerably than those of hardware. To know understanding of software, it is very important to examine the characteristics of the software that make it different from the other things which humans beings build. When hardware is built, the human creates a procedure like analysis, design, construction. It is ultimately translated into a physical form. If we create a new computer, our initial sketches, formal design, drawings, and breadboard prototypes evolve into a physical product like VLSI chips, circuit boards, power supplies, and etc. First, software is developed or engineered. It is not manufactured in the classical sense. Some similarities exist among software development and hardware manufacture. The two activities of the software are fundamentally different. In the both activities, high quality is achieved by good design, but the manufacturing piece for hardware have to face quality problems that are non-existent or easily corrected for software. Both activities are dependent on people, but the relationship among people applied and work accomplished is entirely different. 2. Doesn't work out. If you look in this picture, figure 1, the failure curve for hardware. The relationship is often called the bathtub curve, like this. That indicates that hardware exhibits relatively high failure rates early in its life. These type of failures are often attributable to design or manufacturing defects. The failure rate drops to a steady state level and defects are corrected, hopefully quite low for some period of time. As the time passes, however, the failure rate of software increases again as hardware components suffer from the cumulative effects of vibration, dust, abuse, temperature, extremes, and many environmental maladies. Stated simply, the hardware starts to wear out. Software is not susceptible to the environmental maladies that cause hardware to wear out. In this theory, the failure rate of curve for software should take the shown in this figure 1. The undiscovered defects will cause high failure rates early in the life program. However, the curve flattens that is shown in this figure 2 is a gross oversimplification of actual failure models for software. However, the implication of clear software does not wear it out, but it does deteriorate. This seeming contradiction can best be explained by evaluating in this figure 3. During its life, software will undergo change, maintenance. As changes are made, it is likely that some new defects will be introduced with it that causing the failure rate curve to spike as shown in this figure. Previously, the curve can return to the real steady state. Failure rate to another change is requested, causing the curve to spike again. Slowly, the minimum failure of the software rate level start to rise. The software is deteriorating due to change. 3. Most software is custom built rather than being assembled from existing components. Let's consider the manner in which the control hardware for our microprocessor is best product for design and build. The design engineer draws a simple schematic of the digital circuitry which can do some fundamental analysis to ensure that the proper function will be achieved, and after that it refers to a catalog of digital components. Each and every integrated circuit, often called an IC or chips, has a component number, a standard set of integration a well-defined interface, and define validated function guidelines. After each part is selected, it can be ordered off the shelf. Sadly, the software designers are not afforded the luxuries which are described lately. There are no catalogs of software components with a few exceptions. It is possible to order off the shelf software but only as a complete unit, not as components that can be assembled into a new programs. Although it has been written about software reusability, we are only beginning to see the successful implementations of the concept. Now we're in my topic. Hopefully you can see this my topic and helpful to you and gave also the more informative. Thank you.